Right now, more than 500 kilometers above your head, one of the most valuable scientific instruments humanity has ever built is slowly, quietly falling. Not crashing, not urgent, not this week or even this year, but falling nonetheless, losing altitude bit by bit, month by month, pulled down by the faint drag of Earth's upper atmosphere, on a trajectory that, if nothing changes, ends with it burning up on re-entry sometime around 2033. That instrument is the Hubble Space Telescope. Launched in 1990, it has cost, by NASA's own estimate, somewhere between $10 and $16 billion over its lifetime, once every repair mission and every year of operations is added up. It has produced more scientific papers than almost any instrument in the history of astronomy, discoveries that rewrote textbooks and appeared in classrooms across the world. And right now, for the first time since the space shuttle program that used to service it was retired in 2011, NASA is seriously considering an attempt to physically save it, using something that's never been tried on a spacecraft this large before, a robotic mission with no astronauts on board, designed to boost Hubble back into a higher, safer orbit. There's no guarantee it will happen. There's no guarantee it would work if it did. And there's a very real, very current debate happening inside NASA right now about whether it's even worth the cost. This is the story of that decision. The machine, the falling orbit, and the robot that might just get sent up to catch it before it's too late. This isn't a manufactured crisis dressed up for a thumbnail. It's a genuine, currently unresolved decision, being shaped in real time by a separate rescue mission launching within weeks of this video going live. And the outcome of that mission may end up determining whether Hubble gets a second chance at all. To understand why NASA is even weighing an option this unconventional, you first need to understand exactly what Hubble is and just how much has already gone into keeping it alive. Hubble launched on April 24th, 1990, aboard the Space Shuttle Discovery, deployed into orbit roughly 380 miles above the Pacific Ocean. Its initial construction cost was estimated at around $6 billion, already a staggering figure for a single scientific instrument at the time, and one that ran years behind schedule and well over budget before it ever reached orbit. But that initial cost turned out to be only the beginning. By NASA's own accounting, adjusted for inflation, the full lifetime cost of the Hubble mission, including its construction, its launch, and every subsequent servicing mission and year of operation since 1977, comes to approximately $16 billion. Earlier estimates from NASA officials, before some of the later servicing costs were fully tallied, placed the figure closer to $10 billion. Either way, it remains one of the most expensive single scientific instruments ever built by any nation. Part of why that cost climbed so high is that Hubble, unlike most spacecraft, was specifically designed from the very beginning to be physically serviced in orbit by astronauts, an idea that seemed almost obvious in the era of the space shuttle, but that nobody has attempted to replicate at this scale since. Between 1993 and 2009, NASA flew 5 separate crewed servicing missions to Hubble, each one involving astronauts physically spacewalking to the telescope, replacing failing components, installing new instruments, and extending its working life far beyond its original design expectations. The most famous of these came in December 1993, when astronauts corrected a flaw in Hubble's primary mirror that had been blurring its images since launch. A repair mission so successful it likely saved the entire program from being considered a costly failure. When Hubble first reached orbit in 1990, its images came back noticeably blurry, and engineers eventually traced the problem to a manufacturing flaw in the shape of its primary mirror, off by a fraction of the width of a human hair, enough to meaningfully distort every image the telescope captured. The 1993 servicing mission installed a corrective optics package, essentially a set of specially designed lenses that compensated for the flawed mirror shape, restoring Hubble's vision to the sharp, iconic clarity that would go on to define its scientific legacy for the following 3 decades. That fix alone transformed Hubble's public reputation from an expensive embarrassment into what many consider the most successful and beloved scientific instrument NASA has ever operated. The 5th and final servicing mission, flown by the shuttle Atlantis in 2009, installed 6 brand new gyroscopes, the devices Hubble uses to precisely point itself at targets across the sky, along with fresh batteries and new scientific instruments, essentially giving the telescope a full mechanical renewal. That 2009 mission was also the last time any human being has ever touched Hubble. When the space shuttle program retired in 2011, NASA lost its only method of physically servicing the telescope. Every gyroscope failure since then, every aging component, every gradual mechanical decline, has had to be managed entirely from the ground, through software and operational workarounds, with absolutely no ability to send anyone up to physically fix anything. And pieces have failed. Of the 6 gyros installed in 2009, several have since stopped working reliably. By 2024, after a series of recurring faults, NASA made the decision to transition Hubble to what's called single gyro operating mode. a configuration engineers had actually planned for more than 20 years in advance, specifically as a fallback for exactly this scenario. Operating on a single gyro instead of 3 does reduce Hubble's overall scientific efficiency, with a 2016 study by the Space Telescope Science Institute estimating roughly a 25% reduction in productivity compared to full 3-gyro operation. But it also meant the telescope could keep functioning for years longer than it otherwise would have, without ever needing another repair. That decision alone is a testament to just how resourceful Hubble's ground team has had to become. But there's a second, entirely separate problem that no clever software workaround can solve, and it's the one now driving this current, genuinely unresolved decision. Every satellite orbiting close enough to Earth experiences a small amount of atmospheric drag. Even at altitudes hundreds of kilometers up, there's still an extraordinarily thin wisp of atmosphere, and over years and decades, that faint drag slowly, steadily pulls satellites down toward lower and eventually unstable orbits. Hubble orbits at an altitude of roughly 300 miles, or about 480 kilometers, high enough to avoid the worst of that drag, but not high enough to escape it entirely. Since 2009, with no more servicing missions available to boost its altitude back up the way earlier shuttle missions occasionally did, Hubble's orbit has been gradually, continuously decaying. At an American Astronomical Society conference in January 2026, Jennifer Lotz, director of the Space Telescope Science Institute, the organization that manages Hubble's science operations, presented updated orbital models placing the telescope's median projected re-entry date at 2033. That's not a hard deadline, and the actual date could shift earlier or later depending on solar activity, which affects how much the upper atmosphere expands and contracts over time. But it represents the current best estimate for when Hubble's orbit becomes unstable enough that the telescope would begin an uncontrolled re-entry into Earth's atmosphere. An uncontrolled re-entry of a spacecraft this large carries its own risks. Hubble weighs more than 11 tons, roughly the mass of a fully loaded school bus, and while most of a satellite this size typically burns up during re-entry, some fragments of denser components can potentially survive all the way to the ground. NASA has, in the past, taken deliberate steps for other large, aging spacecraft to ensure a controlled, targeted re-entry over unpopulated ocean, rather than leaving the exact re-entry location and timing entirely up to chance. For comparison, NASA's own Compton Gamma Ray Observatory, a spacecraft of roughly similar scale to Hubble, was deliberately deorbited in a controlled manner back in 2000 after one of its own gyroscopes failed, specifically to ensure any surviving debris fell safely into the Pacific Ocean rather than an unpredictable, uncontrolled location. Without some form of intervention, whether a full reboost or at minimum a controlled deorbit plan, Hubble's eventual re-entry around 2033 would, by default, follow a far less predictable, uncontrolled path, which is part of why NASA takes the timeline of this decision seriously well in advance rather than waiting until the orbit becomes critical. That's the immediate physical problem. But underneath it sits a financial one that's arguably even more central to the decision NASA is currently weighing, keeping Hubble operational costs real money every single year, indefinitely, for as long as the telescope keeps functioning. NASA spent $8 million operating Hubble in fiscal year 2025 alone, a figure surpassed only by the James Webb Space Telescope among all of NASA's active astrophysics missions. That's not a one-time cost. It's an ongoing annual expense, covering everything from the ground team monitoring the spacecraft's health, to the scientists processing its data, to the physical infrastructure required to keep receiving its observations. As one NASA official put it plainly in 2026, Hubble was built in a fundamentally different era of engineering, and that makes it inherently more expensive to maintain and to extract the best possible science from, compared to more modern spacecraft designed with today's technology and today's operational efficiencies in mind. So NASA is now facing a genuinely difficult, two-part question at the same time. The telescope's orbit is slowly running out, and even while it's still working, it's expensive to keep running. Any decision about Hubble's future has to address both problems simultaneously, which is exactly what's made the current proposal on the table so interesting. Here's where the story becomes genuinely current and genuinely uncertain, because this decision is playing out in real time, right now, in the middle of 2026. For years, the most talked about proposal to save Hubble involved SpaceX. In September 2022, NASA signed a Space Act agreement with SpaceX to study a Hubble reboost mission using a Crew Dragon spacecraft as part of the company's privately funded Polaris program, a mission that would have involved astronauts aboard a Crew Dragon capsule physically docking with Hubble, raising its orbit, and potentially even performing minor repairs, including installing new gyroscopes. But in June 2024, when NASA officially transitioned Hubble to single gyro mode following its most recent gyro failure, the agency also announced it was stepping back from that private servicing mission, at least for the time being. Mark Clampin, director of NASA's Astrophysics Division, explained that the agency's primary concern was risk. Specifically, the possibility that an unproven private servicing mission could accidentally damage or contaminate Hubble's mirror, for instance, through exhaust from the visiting spacecraft's own thrusters. NASA didn't rule out reconsidering a reboost mission at some future point, but for 2024, the answer was no. That brings the story to now. As of June 2026, NASA's position has genuinely shifted, driven largely by an entirely different mission that has nothing directly to do with Hubble at all, but that's changing how the agency thinks about what's possible. NASA's Neil Gehrels Swift Observatory, a gamma-ray astronomy spacecraft much smaller than Hubble, but facing the exact same fundamental problem of a decaying low Earth orbit, is currently the target of an actual funded robotic reboost mission. NASA awarded a $30 million contract to a company called Catalyst Space to build and launch a small servicing spacecraft named Link, specifically designed to rendezvous with Swift, attach to it, and raise its orbit before it re-enters. As of early June 2026, the Link spacecraft had already completed environmental testing at NASA's Goddard Space Flight Center and arrived at the Wallops Flight Facility in Virginia, being prepared for integration with the Northrop Grumman Pegasus XL rocket that will launch it, with a launch window expected later that same month. According to Sarah Donegal-Goldman, a NASA official involved in the planning, the Swift reboost effort has revealed something genuinely useful. This kind of robotic servicing mission is now more affordable than the agency originally anticipated. As she put it, these reboost capabilities are becoming available to NASA at costs lower than expected, which makes the potential return on investment noticeably more attractive than it looked just a few years earlier. And critically, NASA officials have explicitly said that if the Swift mission succeeds, and if a similar approach can be made cost-effective for a much larger spacecraft, they are genuinely open to attempting something comparable for Hubble. That's the actual gamble unfolding right now. It's not yet an approved, funded, scheduled mission the way Swift's rescue is. It's a real possibility being actively evaluated, contingent on two things happening in sequence. First, that the Swift reboost mission, scheduled to launch within weeks of this video, actually works as designed, proving the underlying robotic servicing technology at a smaller scale. And second, that NASA can find a way to make a similarly styled mission for Hubble affordable enough and safe enough to justify the investment, especially given the earlier concerns about contamination risk that led the agency to step back from the SpaceX proposal back in 2024. It's worth being clear about the scale difference involved here because it's a meaningful part of why this is genuinely uncertain rather than a simple, guaranteed follow-up. Swift is a considerably smaller spacecraft than Hubble, and its Link servicing mission was specifically designed around Swift's particular size, docking points, and orbital characteristics. Successfully reboosting Swift wouldn't automatically prove that the same exact approach, hardware, and spacecraft design could safely scale up to something as large, as old, and as scientifically sensitive as Hubble. NASA officials have been careful to frame the Swift mission as evidence that this general category of robotic servicing is becoming more viable and more affordable, not as direct proof that a Hubble-scale version is already solved and ready to go. If it does happen, the payoff described by NASA officials goes beyond simply extending Hubble's working life. One NASA official has specifically described a successful Hubble reboost as a potential bridge, keeping the telescope operational long enough to overlap meaningfully with NASA's next major flagship observatory, the Habitable Worlds Observatory, a next-generation optical and ultraviolet space telescope currently in development, with a planned launch sometime in the 2040s. In other words, saving Hubble now wouldn't just be about preserving a historic instrument for its own sake. It could mean keeping continuous optical and ultraviolet observing capability running, without a multi-decade gap, all the way until its true successor is ready to take over. It's worth appreciating just how technically difficult a robotic reboost of something Hubble's size would actually be, even setting aside the cost question entirely. Hubble was never designed with an easy, standardized docking mechanism in mind for uncrewed robotic spacecraft. It was built in an era when servicing meant astronauts physically working with tools, not an autonomous vehicle attaching itself precisely enough to safely raise the orbit of an 11-ton telescope without damaging any of its delicate optics or instruments in the process. That's exactly why NASA's earlier concern about contamination risk from the 2022 SpaceX proposal was taken so seriously. A servicing spacecraft's own thruster exhaust, even in small amounts, could potentially deposit residue on Hubble's sensitive mirror surface, permanently degrading the image quality that makes the entire telescope valuable in the first place. Any future robotic reboost attempt would need to solve that exact problem, using propulsion and docking methods specifically designed to avoid contaminating the instrument it's trying to save. It's worth stepping back and asking why any of this is worth the risk, the cost, and the genuine uncertainty involved, rather than simply letting Hubble's mission wind down naturally. Because Hubble isn't just historically significant, it's still, right now in mid-2026, an actively productive scientific instrument. In just the first half of this year alone, Hubble has contributed to a steady stream of new discoveries, identifying a previously unknown type of dark matter-dominated cosmic object in January, capturing a comet unexpectedly fragmenting into multiple pieces in March, and working jointly with the James Webb Space Telescope in June to help confirm an entirely new class of ancient stellar remnant within our own galaxy's central bulge. Unlike Webb, which observes primarily in infrared light, Hubble's unique strength lies in ultraviolet and visible light observations, wavelengths that Webb simply isn't designed to capture. That means Hubble isn't a redundant aging backup to a newer instrument. It's doing genuinely irreplaceable science in a part of the light spectrum no other currently operating space telescope can match, and it will keep doing that science for as long as it keeps functioning. There's also a broader strategic reason this decision matters well beyond Hubble itself. If the Swift Observatory reboost mission succeeds in the coming weeks, it will represent the first time NASA has successfully used a dedicated, purpose-built robotic servicing spacecraft to rescue an aging satellite from a decaying orbit. That capability, once genuinely proven, wouldn't just apply to Hubble. It could fundamentally change how NASA and other space agencies think about the lifespan of every future spacecraft placed into low Earth orbit, potentially saving vastly more money over time than the cost of building expensive redundancy or replacement missions from scratch. Hubble, in that sense, isn't just weighing whether one telescope survives. It's potentially the highest profile, highest stakes test case for an entirely new era of in-space servicing technology. And there's a genuine financial trade-off baked into this decision that NASA has been transparent about. Extending Hubble's life through a reboost mission only makes sense if the annual operating costs, that roughly $99 million a year, can themselves be brought down alongside the one-time cost of the reboost mission itself. NASA is explicitly weighing whether a healthier, longer-lived Hubble, operating more cheaply than it does today, is worth more scientifically than simply letting the telescope's mission end naturally around 2033 and redirecting that annual budget elsewhere. That's not a simple, obvious calculation. It involves genuinely comparing the scientific value of continued Hubble observations against every other possible use of the same money across NASA's broader astrophysics portfolio. It's also worth noting that this isn't purely a NASA decision made in isolation. Hubble has always been a joint mission between NASA and the European Space Agency, with ESA contributing funding, hardware, and staff to the mission since its earliest planning stages back in the 1970s. Any major decision about Hubble's future, whether to fund a reboost, how to structure reduced operating costs, or how to plan for an eventual safe deorbit, involves coordination between both agencies, adding another layer of institutional complexity to a decision that's already technically and financially difficult on its own. So here's where this actually stands. Right now, as you're watching this, Hubble's orbit is decaying, with a current median projected re-entry date around 2033 if nothing changes. NASA passed on an earlier private reboost proposal involving SpaceX back in 2024, citing contamination and technical risk concerns. But as of June 2026, the agency has genuinely reopened the conversation, directly inspired by an active, funded robotic reboost mission currently underway for a smaller spacecraft, the Swift Observatory, a mission whose success or failure in the very near future could directly determine whether a similar rescue gets seriously proposed for Hubble. Nothing about Hubble's own reboost is confirmed. No contract has been awarded. No launch date exists. NASA's own language on the subject remains conditional, open to the idea, actively interested, but explicit that the costs need to come down further before it becomes a real, funded plan rather than a possibility under evaluation. Whether a 500-kilometer high, $11-ton billion-dollar telescope gets a second chance at a longer life may come down, in large part, to whether a much smaller robotic mission, launching within weeks, works exactly as designed. The real question isn't whether Hubble still has valuable science left to do. It clearly does. New discoveries have kept coming throughout 2026, in wavelengths of light no other currently operating telescope can capture. The real question is whether NASA decides the cost of saving it is worth paying, and whether the untested technology needed to actually do it proves itself in time. If you want to be here the moment NASA makes a final call on Hubble's future, or when the Swift reboost mission either succeeds or reveals problems that change the entire calculation, subscribe to the channel and turn on notifications, because when that decision comes down, we'll break it down here with the real data, not the invented version. One telescope, one decaying orbit, a decision still being made. Whatever NASA ultimately decides this moment, mid-2026, with the Swift rescue mission about to launch and Hubble's own fate still genuinely undecided, is the point where 3 decades of one of humanity's most productive scientific instruments either gets extended into a fourth, or begins its final countdown toward 2033. Thanks for watching.